I think for this one, I would do you iterate through each subarray from index I to the end, and you make an array of the current found maximum, like here starting from 0, 6, 8, and then from here it'd be just 8, here just be just 8, 5, 7, 2, 7, and then just 7. Wait, does that make sense though? I mean, here everything before is bigger than 2, so we can't go to 2. I don't know. Contest is in 3 minutes. I'm just looking at the daily right now. So 6, 4. I want to check in this subarray and look at the maxes and find the first one that's bigger than the max of these two, which is 6. First one is 8 at index 2. Then you got 0, 3, so 0, 1, 2, 3, so 6 and 4. You know it has to be after the max index, so between these two. And the first that's bigger than these two, so that's the 7, and that you can find with binary search. 2, 4, 0, 1, 2, 3, 4. So here the first one that's bigger than 2 and 8. There's none, so it turns -1. I think this approach might work. For any query, it would take the initial generation. How long does it take? Oh, it's n squared though, the initial generation of these arrays. And after the search is log of n times the number of query times log of n. So overall the algorithm would be n squared. Might be a bit slow. So I think finding a way to optimize this idea of finding the maximum after a certain index, or not the maximum, being able to find the maximum after a certain index. I think that's where probably a monostack comes into play, but I'm not sure how to use it. Alright, contest is soon. Where's the time? I don't get seconds. Feels bad. It's like in 10 seconds. Oh, there we go. Minimum number of operations to make elements in array distinct. You're given an integer of an array nums. You need to ensure that the element in the arrays are distinct. To achieve this, you can perform the following operations any number of times. Remove 3 elements from the beginning of the array. If the array has fewer than 3 elements, remove all remaining elements. Note that an empty array is considered to have distinct elements. Return the minimum number of operations needed to make the elements in the array distinct. So not distinct yet. So after 2, so I guess you count them, you decrement, and then how do I check they're all 1? I guess when the maximum one gets decremented, then the maximum changes. But should I brute force it? So I don't know. There's some kind of loop, or yeah, I guess you could call the current one. Can I count it? They're all numbers, and okay, they range from 0 to 100. I think the best way would be counting. And how do I make sure at the end that everything has a count of 1 without having to check everything? I think it's just you keep track of the maximal element, or yeah, I'm not sure about that. Maybe I'll brute force it because it's an easy. Yeah, fuck it. So oh, I should just make it so that when there's one more element, we remove it from the count. Or upon existence, I set it to 0, but I don't actually increment it. And then when it hits 0, then I remove it. Or something like that, yeah. Yeah, so while true, something like that. Or while, yeah, I'll just add, so we put everything, so for n in nums, count of n just equals 1. And then while count, so while we have stuff inside this counting dictionary, yeah, so we're gonna remove 3 at a time, and if any one of them hits either 1 or 0, then we remove it from the dictionary. Yeah, 1 or 0 can be counted as a removal from the dictionary. What if there was 1 and then you could try to remove it? I guess we just do nothing. So I'll count for I guess we have current is at index 0. So then we can do count. Yeah, so for I in range of 3, yeah, we're gonna do count at, okay, so so I'll use current, so it'll be current times 3 plus I. and then minus equals 1. And then if this new count here, whoops, is equals to 0, 1, or well, less or equal than 1, then we'll remove it. So how do I ensure? And if it doesn't exist, then we skip it. Yeah, so we just ignore the operation if it doesn't exist. So if not, or if this is not inside, not, whoops, what the fuck? So because we delete it, subtract 1. If it's less or equal than 1, remove this from count. And at the end, oh, and current, I guess every time that I remove current is going to increment. So I guess we return current. I'm not sure if that'll work. Okay, seems like I have an infinite loop. Whoopsies. It's okay for I. Oh, okay, I forgot to increment current. So I in range of 3, if not current times 3 plus 1. Oh, whoops, if this is not in count, then we continue. Else we'll decrement by 1. If it's less or equal than 1, we'll remove it. Okay, I'm trolling something real bad. I'll just print count that every time, see what happens. Okay, so at the beginning we have 1, 1, 2 2s, this 3s, we have 1, 2, 3, the 5s have 1, and then 7. Okay, we remove 1, 2, 3, so 1 disappears. 2 should disappear as well. And then 3 should have decremented. Oh, 3 did not decrement. That's an issue. Oh, hey Patrick.
Oh, I'm late.
You're late.
Sorry, I was at the gym.
That's okay. I'm trolling the question 1. It's so bad.
Question 1. Okay.
I mean, oh, whoops! It's in range of 4.
Distinct elements.
That's
Remove
why.
3 elements from the beginning.
Oh, wait, output limit. Oh, because I'm printing. Oh, but I'm still stuck in an infinite loop. That means. Wait, so I'll just keep printing it then. Not sure what I'm trolling. Wait, no, it should be in range of 3.
Bro, isn't this trivial? Just brute force.
I know. I'm doing something with count, like with counting in a dictionary. Should I like purely brute force it?
Like put them in the deck and then just like pop from the front, right?
Deck. Yeah, but then you linear check every time if it.
Yeah, honestly, like yeah, n squared.
Damn, maybe I should. I'm trying to do
I
it
think,
like linear time.
maybe.
Wait, why doesn't this decrement?
Is question 2 the same but with higher
okay,
constraints?
I think I know why I'm trolling. It's because here, when I remove, I should be reading from nums here. Oh, that's why. So, I should call this n equals this, and if n is not in count and blah blah blah, else n decrement, count n less than whatever, delete. The fuck, index out of bound. There's no way. Oh, and there's a chance it goes out of bound. Or yeah, so if Something like that. Okay, 3. Oh my god, 3, 2, 2. Oh man, it's so bad. It doesn't work. Oh, I'm trash.
No, it's okay.
Wait, here.
Don't worry. Confidence.
6, 7, 8, 9. I removed the first 3. Okay, these are 3 gone. Wait, oh, wait, it should check from the beginning. Oh, man, okay, this counting shit is gay. Damn, I'm on YouTube. It's cringe. I think at the beginning I should filter out everything that's equals to 1. So for... what is it? For n in count, if count n equals 1, then delete count n. Something like that. Oh man, okay, I can't do that. Oh, okay, no, I just brute force it.
Oh, just brute force it, don't worry.
Did you brute force it and it accepted?
Let me see, I'm not done yet.
Okay.
I gotta pop here.
Wait. How do I get all the keys? How do I get all the keys of count? Count.keys? Yeah,
How do you get all the keys?
yeah, dot keys, huh?
Dot keys, length, yeah, length keys.
Wait, what? Man, it doesn't let me do that. Man. Oh, how do I do it? Oh, I'm struggling. It's bad. I need to brute force it. It's like I'm getting skill diffed. Okay, so for while true.
My code is trash. Holy shit.
Okay. Okay. Okay, it's a count, and then for n in range in nums from yeah, I'll have the answer equals to 0. So then it'll be the answer times
cool.
times 3 until the end.
Ok.
Okay.
Ok, je pense que ça marche. Brute force. Submit. Accepted. Ok.
Okay. Count n is greater than 1. Then return answer. Oh wait. No. If it's bad, yeah, if we find something bad, then we can just continue. Wait, I want to continue this outer one. Yeah, I want to break out of this, right? And then we go for the next iteration. Okay. For n, blah blah blah, count plus equal 1 if count greater than 1 break. Oh no, I should have a flag. So is unique. I don't know, something like that. Is distinct. True is distinct equals false. Break. Otherwise, if is distinct, and then return the current. something like that. Oh, I forgot to increment my answer. And there's no current, it's answer. Okay, 2, 2, 0. Okay, let's submit this shit. Accepted. Okay, we go next. Maximum number of distinct elements after operations. You're given an array of nums and an integer k. You're allowed to perform the following operations on each element of the array at most once. Add an integer in the range minus k to the element. Return the maximum possible of distinct elements and nums after. Oh, what the fuck? I don't get it. Oh, add an integer in the range. Wait, what? Okay, I can add any numbers between that range?
Yeah.
So it's asking how many times can I add these numbers until
No,
like...
what's the how do we maximize the number of distinct elements?
Wait, so at the beginning we have 1, 2, 3, 4. Okay, and then what operations did it do on it?
I think we're doing minus 2, minus 2, minus 1, minus 1.
You're allowed to perform the following operation on each element of the array. Oh, okay. So like on every single.
On every number, we can do it once.
Okay, and we pick any one of them that I want.
Yeah.
Okay, and now are they all distinct? 1, 2, 3, 4, 5, 6. Okay. So we want to maximize distinct elements. Okay, so if elements are distinct, if we have 6 elements that are distinct, no, they're not necessarily consecutive. Oh, fuck. Wait. Fuck. So if you have k, answer is 3 because we have 4. We can have 3 and we can have 2. Oh, man. What's next? Oh, man. Q3, Q4 are hards.
Both?
Yeah.
That's okay. We can do Q3 maybe.
We can look at it.
Let's focus on Q2 for now.
Okay, Q2 for now. So here we have 1, 2, 2, 3, 3, 4, 4. So now we have 1, 2, 3, 4 distinct elements. And we want to see if we can increase the number of distinct elements. So 2 can become anything between 0 and 4. Can we do like a cascade? Like, let's say like you have one.
It would be greedy. Like we sort nums and then we just like start from minus k and then we increase k with each number.
I don't think we need to. Do we need to sort? Oh yeah, maybe because a set wouldn't work because we'd lose like the repeats.
No, that. What do you mean set?
Because I wanted like a fast search. For example, my idea would be like you have 1, 2, 2, 3, 3, 4, 4. So 2 is repeated. So you're trying to make it distinct. So you're taking a 2 and see what can you turn it into. So 2 you can turn it from anything between 0 and 4. And none of them are valid. So then what you can do is you can try to.
How do you check that? How do you check if between 0 and 4 some numbers are valid?
Yeah, so I guess with a set, right? Something like that.
But that's like linear. Because you have to check every number until you find a possible one.
No, like linear, like within the range, right?
Yeah, within k, and k is like 10 to the 9th.
Yeah, that's true. Fuck. Is there a binary way?
What do you think if we sort it and then like we start from minus k, right? So for the first example, we're at -2 at the beginning. So we do 1 minus 2, and then we go to the second element and we increase k. So now k is -1. We do 2 minus 1.
Wait, what?
And then so like
Okay,
we start from the beginning with minus k, and then we kind of add that number, that k count, to the element.
Oh, I see.
And then for each number we increase k by 1.
Wait, so I think I see an idea, yo. So 1,
but then
2, 3, 3, 4. This is already sorted, right? And you have k equals 2.
Yeah.
So yeah, since they're already sorted, what you can do is take a greedy approach. This 1, you take it to the leftmost value, so it's -1, right?
Yeah.
And then -2, this 2, you can try, you set it to also the minimum value that doesn't clash with anything on its right, on its left, so which would be 0, right? And then this 2, minimum value would be 1, right? And then this minimal value would be 2, minimal value would be 3, minimal value would be 4, and this would be sorted too, right? So you just need to check the one directly before. You don't need to check the whole thing. Does that make sense?
What do you mean check the one before?
So let's say, so here, this one, first one, there's nothing before, like in this list, there's nothing before, so we just go full greedy, right? So -2 would be -1, right? And then this one, we just have to compare to this one. So the options that we have is 0. I'll give you an example. Okay, so
you
here
don't even need to compare it. Just add -1 to it,
no,
and it will never be less than
because
the one
here,
on the left.
If we do like -2, then it won't work here.
Oh yeah. So my idea was, let's just, at the end of our operations, let's just put everything in a set and return the size of the set.
Size of the set.
So we don't need to do checks for like distinctiveness among elements.
Wait, so how would you?
I think this grid approach for sure ensures that we maximize the distinct elements. I think, unless I'm being a stupid.
Yeah, that's
which maybe.
My idea would be to have an array, and then at the end you return the count of that array. But what happens?
Yeah. So we have an array.
Yeah. So you have like -1, -1. This would be 0, 1, and then this is 2, 3, 4. But then I would have to think about like, what if there was more 3s? How would that affect the solution? So you have this 3 would be forced into a 4. This 3 would be forced into a 5. Let's see, there's another 3. And there was a 4 like this. In this case, what would you do? So this 3, you can't do anything with it, so I guess you just skip it. And then this 4, the best you can do is 6. And I guess that would be a binary search. Yeah, so you have this 5, and you search within the range. In this case would be from 4 minus 2, so it would be in the range of 2 to 6, right? So you have like 2 and 2 to 6, and you binary search for the first one bigger than 5, or rather it'd be like 5 plus 1, right? So you'd be searching for the last element of the array plus 1 inside this range. So you have n log n for the initial sort, and then this again is n times, and then this search space is log of k, I guess, log of 2k. What do you think of this?
Maybe. Yeah. I got lost. I was coding while you were talking.
Oh, you have your own idea? We can implement each our
own
idea.
I was implementing my previous idea, but I don't think it's gonna work. I think maybe.
You want to try my idea?
Hey, can you just like TLDR what you just said to me?
Yeah, so here I gave you an example like where kind of like this 3 is limited, right? Because then you can't insert a 5 here, because and this 3 can't go to 6, right? So since since this one is no good, we just skip it, and now we're at 4, right? You know, 4. The options that 4 can turn into is within the range of 2 to 6, right?
Yeah.
And you're looking for any, like the first one that's bigger than 5, right?
The first one is bigger than 5. Okay.
So you're binary searching for 6 within this, right?
Oh, so you're okay. You're binary searching in a range of like the constraint is like 10 to the 9 times 2.
Yeah, log of
Log,
2k is not that bad. Yeah.
No, that's really pretty good. Okay.
Yeah, and also, what if there was a case of instead of 4, you had like, let's say like, I don't know, 100, right? So you'd be searching for 6 in the range of 98 to 102, right? Oh, but that would still work because you're looking.
Oh, you're just gonna, yeah.
You're looking for the
Are you
first
gonna
one
choose
that's.
the leftmost?
Yeah. So it's either we're searching for 6. It's either like at 6 it exists, or yeah, because it gives us the index of where we would insert it, right? So the bisect left. So that would give us the 98. And if the 6 existed, then bisect left would give us exactly the 6, right?
Wait, why 6? That the index?
Because after 5, we're looking for a 6. The first thing that's 6 or bigger.
Okay, but you're looking for it in a range of 98 to 102.
Yeah, so the first one that's bigger than 6 is 98.
Oh, okay, yeah.
Yeah, and you know this is sorted, so it's okay because the next number has to be bigger than 100 that we're checking
The
here.
first number is okay. Yeah, no that. Okay, so we're binary searching on each number, so it's like n log n, n log k, 2k. Okay.
Yeah, so that's the approach I'm gonna try for.
Yeah, I think that works. I might do your thing too.
Someone said try brute force. I got accepted. Wait, I don't even know how to brute force this shit.
What?
How the fuck would you brute force this?
You can't. The brute force would be like
how would you
2k times n.
How would you implement brute force? Instead of binary search, you linear
You
search?
just like, yeah, you linearly look through the range of 2k.
You
Like
could.
instead of binary searching, you just linearly.
Yeah, you could. Yeah. So you sorted nums. I guess you'll have the an array. Do you even need an array? You just need to keep track. I'll do an array for now because that's how I visualized it. And for nums. Wait, these nums. What are the range of nums? Okay, nums is at least the numbers inside the arrays are at least 1. So I guess I'll put 0 in the array at the beginning, or fuck it, yeah. No, that wouldn't make sense. Okay. Or maybe I'd start from 1 to the end, and then in this array of answers at the beginning, 0 minus k. Is it a bisect left that I want? I mean, it doesn't matter if it's a bisect left or right. Yeah.
No.
A bisect left, it's you give the input array, right? So
yeah, I don't really use it often in Python.
Yeah, you implement your own binary search.
Yeah.
Okay.
No, but use bisect left.
Yeah. So the array that we're, so I guess this is the range of n minus k to n plus k plus 1. Does range return a list? I think so, right?
Yeah, it's not really a list type, but yeah, kinda. Yeah, it's enumerable.
Yeah, and then we're searching for array minus the last element plus 1. I'll just call it X for now. And then, so that's the element. So it's either 6 or it's the first one that's bigger than 6, right? Is there a chance that it can't be found? Yeah, there's a chance that it can't be found, this element here. Okay, yeah, so if it can't be found, it'd be if X is greater than or is equals to n plus k plus 1, and continue. Otherwise, it's array. Oh man, okay. Range object index out of range. What? Oh, whoops. Okay. So 6 and 3. It worked on the test case. Accepted. Did yours
You're
work?
so cracked! Holy!
Huh?
You're so cracked.
Thank you. Do you know how to implement it?
I'm trying to go for a not binary searching.
You're linear searching?
No. Could I think? I'm just like prototype. If it doesn't work, I'll just binary execute it.
I'll look at the next question meanwhile.
Okay.
Oh, someone added me a friend request. Probably a YouTube watcher. I got 34 views on YouTube right now.
30 or 20?
31 right now.
30.
Yeah.
Whoa.
I wonder who he is. I don't know how the guy
No
fucking
one.
brute forced it. There's a guy called Deanie Kings. He said Q2 he brute forced it. Like, I legit don't know how to brute force it. Maybe when he said brute force, it's a linear search. Okay. You need to minimize the length of the longest substring of S such all characters are identical. Return the minimum length. What the fuck? Reading comprehension check. Given a binary string S of length n and an integer num ops. The following operation on S at most. Okay. Select any index I. Okay. And flip it. Okay. Minimize the length of the longest substring of S such that all characters in the substrings are identical. Minimize the length of the longest. Minimize the length of the longest substring such as all the characters are identical. Okay, you're kind of like trying to break them apart. So here it's 2 by inserting it here. Okay, I get it, I get it.
Do I just YOLO and submit? Fuck.
Did your
I don't
test
wanna
case
lose it.
work?
Yeah.
Yeah, YOLO it. Fuck it. Anyways, like you don't lose actual 5 minutes. It's
Oh,
just
wrong answer.
wrong
Fuck.
answer. No.
6 test cases. Didn't pass.
Maybe it's
I
the
have an edge
continue
case.
cases.
Yo.
Because for me, I had no edge cases. Did you make sure that if what did you binary search?
No.
Okay, never mind. Because for me in the binary search, if like the index is equal to the length, it means it couldn't be found. So I would skip that number. Oh my god, what the fuck? Not sure about how to do this one. Smallest of string with identical characters I. And I think Q4 is just like, you know how you have like two sum and three sum, or like you have like a question like
Okay.
x1 and
Yeah,
then
yeah,
x2. It's literally that.
Yeah.
It's like smallest substring with identical characters 1, smallest substring with identical characters 2. Wait, what the fuck? Why did the questions look exactly the same? I don't see the difference. Wait, there's no fucking way. It's
The constraints.
Q3 and Q4 is literally the same thing.
The constraints aren't different?
Like constraints. 10 to the power 5. Oh yeah, the length of the string is different. Does that mean that Q3 could be brute forced?
Maybe.
Because that means the length of the string... Here the length of the string is just 1,000. So could you do some backtracking solution? Or like test all the ways you could do it? Oh man, that seems so cringe though. The number of ways to do it would be n choose num ops. Eesh. So worst case is what? 1,000 choose 500. What's that? Okay, it's a huge number. I don't know if Denny Kings is trolling me. He's telling me that Q4 is easier than Q2. Pretty sure he's just trolling. You have 0, 0, 0, 0. You want to apply at most 2 operations, such as to minimize the longest substring of S such that all characters
Oh,
are...
accepted. I'm so cracked. Okay.
You're correct. Now help me with Q3 because I have literally no idea how to do it.
What the fuck is the binary? Okay, never mind.
I know this is the solution. Fuck, but how? I mean, another solution would have been... Okay. Doesn't really work. I mean, I do this first to try to split them apart. So then instead of 4, now you have one with 2 and one with 1. And then here, if you put a 1 here, it's really bad because of this. Well, yeah, it's better to put it here. But how do you know where to put it? Fuck. I don't know. I mean, there's two solutions for this one. Okay, now this guy tells me brute force is impossible for Q3.
Bro, don't listen to him. Stop reading your chat. What the fuck?
I don't care, it's just funny. I think this guy is trolling, honestly.
Okay, so what if we just count the longest substring?
Yeah, and then?
The longest substrings, plural, and then
You try to cut them.
save them. We put them in all these lengths. We put them in a sorted array, right?
Mm-hmm.
And then we just in a heap, max heap, and then we just half each of them, and then we decrease num operations, right? Because technically,
but
num operations.
having is not always the best choice. Because let's say I have 6 numbers.
By 2 is not the best choice.
Half is not always the best choice.
Why?
I'll give you an example. If you look at my screen, I think you need 8. 1, 2, 3, 4, 5, 6, 7, 8.
The gym session.
So let's say you have this, right? All zeros, and you have 2 operations, right? The best way of splitting would be here and here.
Oh.
Yeah.
Oh.
If you cut in the middle, then you would have griefed.
You're right. Yeah. Okay, so how do we do this?
I don't know, man. I'm hard stuck.
We have 47 minutes.
Yeah, I mean, basically all our time is set on this one. I think if we have Q3 and it's like an optimized solution, you basically have Q4 for free. It's just
Okay, let's come up with the optimize already.
But we just need a working solution, at least one that's not necessarily optimal time complexity. Because another case that you have to worry about is what if it starts affecting a neighboring one. Let's say you have something like this. I don't know, let's say you have all ones here and then all zeros here. If you flip this one, it's gonna go and increase this one by 1 as well.
Yeah, but that's not the most optimal, right? Unless you have 4 num operations. No, but
yeah, because if it's just a 4, these ones, these are the 2 possible ways to cut them up in 2 operations. And one of them would increase the number of this one.
Oh, yeah, you're right.
Yes. So that's just an example of how you can't just take this alone and ignore this part.
Yeah, bro. I think we have 1,000 elements. We can brute force this.
But how do you brute force it? You flip everything?
Q4 is a DP. So we just recursively try all possibilities, I guess. Or something.
And how would you DP this part? What's getting DP'd?
You just add caching and that's DP.
Yeah, but what are you caching?
Let's come up with a recursive function that does this.
We're doing all the possible ways of doing it.
Yeah, how would you do it?
But the worst case would be you have length 1,000 and you choose 500. There's 500 ways of picking them, right? So that'd be 1,000 choose 500 to flip. And that's a huge number. 1,000 choose 500.
Right. No.
But if we were to brute force it, would it just be brute forcing, flipping, and then checking? Is there a fast way to count?
Oh yeah, yeah. There's a constant time function that counts the number of set bits.
Yeah, but you want like
it
of
doesn't check
the
consecutively.
number of repeats in the
Yeah, no.
yeah. You want the you want the longest substring of all the same.
Yeah.
I don't know if there's a fast way of doing
No, it has to be linear.
that. Man, this is so pain. Sliding window? How the fuck would you sliding window this shit? The guy's like sliding window. I ask how, he's like, I don't know. Yeah, and I say it's a graph problem, huh? What if we BFS this shit? Oh man. Why don't you brute force it? Huh? Is this actually the way to brute force it? You wanna you wanna write a brute force solution?
I mean, if we can come up with it, yeah.
Okay, how would you come up with it?
Because we can't just like check every bit.
I mean the brute. I don't know, but why? But I feel it's binary search. There's no fucking way this is binary search.
Oh, maybe.
There's a guy that said that he brute forced it, but it's stuck on 0, 0, 0, 0. I mean, how would brute force it is doing combinations of all the combinations of ways to flip them. So, oh yeah, you just have like a yeah, I know how to brute force it. You'd have a set of like the indexes that you choose to flip, and then you just you just pick an index, and then from that index to all like the rest from the range from like the biggest one to the end. You just pick another one, and etc. Fuck it, I'll brute force it.
What? Please say.
Hmm?
I'm confused.
It's kind of. Do you know how to like create permutations?
我不知道了.
Okay, permutation is basically like you do like let's say permutations of 10, like from 1 to 10, right?
Yeah.
You're just gonna pick like 1, and
Yeah,
then
yeah, but we can't do that if you have a constraint of 1,000. That's too much.
yeah, but I just don't know what else to do, so I might as well try the brute force.
Okay.
You see what I mean?
How to?
Huh?
How to?
How to brute force?
No, I'm saying.
Wait, what?
How the?
Huh? What?
How the?
How the? Oh, you're fucking speaking Chinese. Holy fuck. 好吧，好吧。Man, people saying sliding window. I don't believe it. Okay, fuck it. I'll just brute force it. How do you brute force this?
Sliding window. Okay, let's think about it.
Yeah, I have no fucking idea how to use sliding window for this shit. I think it's capped, the sliding window.
Yeah, same.
Wait. Oh yeah, it has to be.
Is there some kind of formula that given like you have tank but then never mind. Shit.
Find range of previous plus 1 till. Oh, whoops. Someone said smells like TLE. Man, I know it's TLE. That's probably not the way. I just don't know what else to do.
Bro, how did some people finish everything in 10 minutes?
Some people are just cracked, man.
What? This guy works at Acuna. It's a quant firm. The guy that finished 6.
Yeah. Oh my god. This is pain.
Bro, it took us like 10 minutes for the first question. And these guys did all 4 in 10 minutes.
I don't even want to write the brute force. We solved the second one. Advait Dongri. Yeah,
What kind of nickname is that?
That's this fucking guy's name on YouTube. Man, I don't even want to write the brute force. It just feels dirty, and I feel like it'll just TLE anyways.
Okay.
Is anyone cleared the question 3?
Use our brain, bro. We need to find a non-brute force solution.
Yeah, I don't
Okay,
think.
what are you trying to do?
The
Put
brute
it back.
force?
Put it, undo. Yeah.
I mean, brute force would just be doing like every possibility. So it'd just be doing every combinations of indices.
What is the complexity of that?
Huh?
What's the time complexity?
That it's exponential. Wait, is it
Yeah, it's not gonna
exponential?
work.
It's factorial.
What the fuck?
Yeah, because it's a length of s. Choose the number of operation, and choose is just it's permutation divided by something.
Okay.
Yeah, so it's I mean, I think factorial is basically exponential. I don't know. Does it exist? Factorial times complexity.
Complexity, yeah, it's like way more than exponential.
Factorial is more.
Yeah.
No,
You get
exponential is more.
Images. Click on images, and you'll see.
Wait, really?
Yeah. Look.
Oh wait. Oh no, but that's two. Oh, okay, true. I was thinking about something else. Wait, 2 to. Oh yeah. Factorial is way worse. Yeah.
Okay. Yeah, that's not gonna work. Bro. 2 brains. You can't
Well, that's
even solve a
true.
question.
Someone said that you can look back through the live. Yeah, just go back. I don't want to explain it. Do you think Jeff knows what he's doing?
Oh. Wait. No, I think Jeff has something tonight.
No, Jeff is like he's in the contest right now.
Oh, what the fuck? He said he wouldn't do it.
No, well then he
Liar.
changed his mind. Like if you check in the Discord server, he said he was gonna do it, but he's soloing it.
Okay. Oh, I don't think he's allowed to.
Well, add Jeff and how's Q3 progress? Oh man, there's no progress in Q3.
Yo, okay, so yeah, I think like binary search might work. Like we basically binary search for can we binary search for the number of distinct elements? Sorry, the maximum.
Let's say we have this string, and we have 3 operations. What would we do? So the idea would probably be to target like these ones, right? These ones are bad. So,
well, either of them. Yeah, it's either of them.
I mean, with 3 operations, I think you'd want to affect both of them, right? Because right now the current biggest is 4, and you're trying to shrink this number. So already you can put a 1 here, right? And then it's still 4, but now we have 2 operations left. And then maybe you put a 0 here.
Bro, I got it.
You got it?
Binary search plus sliding window.
Ah, how?
So it's like, okay, we binary search for the minimum substring length with distinct elements. Sorry, same elements, right? So in this case, it can be from 1 to 4.
1 to
if we
4.
don't apply any operations, it's 4.
What do you mean?
Right?
Yeah. 4.
So if you don't apply any operations, it's currently 4.
Yeah, it's this.
So
or this.
we binary search in the range from 1 to 4.
Okay, so we're
like the most optimal is like having like 1 length, right? So then let's say now we binary search, so we go with 2, right? In the middle. We're like, okay, so now
it's counting the
let's
number
use a
of
sliding
operations.
window of length 2, right? And after every 2 that are the same, we flip a bit.
Wait.
So now it would be like index 2, so the third element, we will flip that one.
Yeah, so this one.
And then that's a new window, which is fine. So then it would go to index 3, 4, 5. Index 4 and 5 are the same, so we would flip 6, index 6, which is that one, right?
Yeah, I get it, but
and then everything else is good.
But that's not. It wouldn't really be sliding window. You're just like checking linearly, right? You're just doing one,
check linearly, 2, flip with a window of size 2.
Yeah.
Does that make sense?
But wait, but why is it a? Okay, you just mean like when the window, like it's size 2. Then wait, after this, would your window extend here?
No, fixed. Because in this case, we're binary searching for 2, right? So we want the result to be 2. And what I mean by that is the longest substring has to be a size 2.
So when this window is here and it's all 1s, then this one gets flipped.
Exactly. Yeah.
And then where does the window start here?
Yeah.
Wait, why would it start
and then
here?
it keeps going. Well, no. It keeps going, but the left pointer also increases because it's a fixed window.
Oh,
Always
okay.
size 2.
Okay, like the window's like this.
Yeah.
Okay.
And then another
Wait,
size 2 from
so you have this.
Yeah.
And then
And then if we can do this, so if we can minimize the longest substring with size 2, then we keep going binary searching and we try if we can do it with size 1.
Yeah, you're counting the number of operations it would take. So let's say this, and we want size, let's say we pick arbitrarily, we want size 2, right? So this would take, there's one operation that's forced here. And then here, another operation that's forced here.
Not there, the one before, right? No, actually, you're not.
Yeah,
sorry,
because there's two
consecutive.
and then this one gets.
Yeah, that's exactly. Yeah, exactly.
And then here.
And then that one, yes, exactly.
So it would take 3 operations. Okay, so that would take 3. Oh, if num ops is equal. Okay, no, but that I hit the jackpot. But let's say we had we were allowed 2 operations, right?
Okay.
Okay, so if we were allowed 2 operations, but it actually took 3. It means that our range is too small. 2 is too small.
Exactly. So now we increase it.
Yeah, so then we check instead between 3 and 4.
Yes.
Oh, okay. Oh.
So we check.
Yeah, that's like a classic binary search, right? Now that I think about it.
Oh. Do you think it will work?
The guy said, yeah, it'll work. He says, I'm too confused. I'm just gonna go play Brawl Stars. Yeah, I get it. I think Jeff could figure this out. Oh, he said nothing? Man, we
got it. We're better than Jeff.
We're cooking.
Okay.
Yeah, there's the guy that's like, what did I say is binary search? Wait, so that range of 2 to 4, how did we decide that?
Honestly,
okay.
I think
it's between 1.
The longest.
Well, the minimum would be 1.
Also,
1 to the maximum. It's from 1 to the maximum of the longest string, right? The longest.
Yeah, but I think we can be more pessimistic and just start at the length of S. Doesn't really matter.
Yeah. Oh yeah, because because if we just we're searching linearly, would it be worse? Then
we can search linearly. I guess.
it's a linear search to find the max length of the substring.
Yeah, I'm gonna binary for anyway, but we
can start pessimistic, and then we can change because the algorithm would still be the same, just the range changes. So the left would be 1, and the right would be the length of S, and then oh man, I'm already brain farting about how to implement this shit. Okay, it's while left is less than right, mid is left is right divided by 2. So the mid is I'll recall it to longest substring or max sub. Okay, yeah. And then 4i in range fuck. Compared to previous one. There's no way you're TLEing question 2 with the same solution. Unless they change their fucking requirements or something for the time limit. Okay, so... if... Right. Okay, if it's the same, we're incrementing.
Oh, can you give me your example earlier?
This one?
Yeah, with 1 1 1 1 1 0 0 0 0. Okay, 1 1 0 0 0.
Okay.
Bro, I didn't get it. I'm brain dead.
What?
4 1s, 4 zeros, 1 1.
Like you don't get how
Can
to
you go back?
implement? Or
0 1 1. Okay, I got it. Sorry.
I'll send you a
Thank you.
screenshot.
No, I got it.
You got it? Okay. Count bits plus equals 1. Okay. The count bit is greater than the max of array means we're flipping. And then this flip could be the start of a new one. Oh fuck, that's so cringe. I can't do that. I think it'll be easier if I just have an array. Int of this high. So I would flip it. Oh man. Okay. Oh man. Oh, what the fuck? Oops. Oh man. Wait, am I getting TLE'd? Oh man. No, that shouldn't be happening. Oh, whoops. Max sub -1. I don't think that's a problem though. This string that's constructing, this array that's constructing is not right. So if max sub is 3, 1, 2, 3, and this one should have been flipped. Okay, that's why. And oh man. Okay, 1, 2, 3. Oh, it still doesn't work. Wait, the count bit should happen after, right? One, two, three. Fuck. I'm bad at implementing. If n is equals array -1. Max sub. Operation +1. Flipped. Equals 0, 0 equals 1. Calculate equals 1. Else. Okay, 0, 0. It says it's equal. No, it should happen before. Okay, right now it's 1. Now it's 2. Okay, now it's 2. Is it greater than max sub? No. Then we just append the 0. Next one is another 0. Plus 1. Is it greater? No. Just append it. Fourth one. Is it greater? Yeah. Okay, operation plus 1. Append the flipped. Oh man, it's not working. One operation. Okay, 1. Oh, what? It stays 1. Why? Count bit.
We have 13 minutes? Bro, we're fucked.
Oh man.
Output 5?
Why is my count bit not incrementing? Oh fuck it, this needs to be an integer. Okay, 2, 1, 1. Okay, fuck it. Let's try to submit this shit. Okay,
Already?
I mean,
You cracked.
if it works. Wait, okay, 2, 1, 1. Okay. No, wrong answer. Fuck. But it passes 893. Oh, you want me to try this test case? What is it? 101 with 1 operation. For that one, I'll put 2. I mean, that one makes sense. Yeah, 2 would work because you flip anything, it'd be bad. Wait, are you forced to use all your operations?
No, you don't have to.
Yeah, you're not. You don't have to, right? That's my wrong answer. Okay, you have.
Okay. Oh no. So
Okay, probably I implemented the search wrong. You have 1101. Wait. Max sub. Expected 1 is the max sub. Oh, okay, because this first one you could flip it. Oh, that's the case I didn't account. If you flip this. Oh. Yeah, what if you flip the first one? How do I take that into account? I guess you do both of them, and you take the one that takes the minimum number of operations between the both of them.
What? What's going on?
Yeah, if I flip the first one. Yeah, if I flip the first one, it changes everything. But then everything depends on it. Wait, oh no, wait, what if I keep the algorithm? Yeah, this should, oh no, it would take too many passes. Yeah, because then if I did this, max is 1, so I'd flip this 1 operation, 2 operations, 3 operations. It would take 3 operations. Oh my god.
Oh.
I hope that's a special case, an edge case.
Do you have some tests we can try?
I have a failing test case. You can look at my screen.
The one we used earlier. Okay, this one is 2. If I do this. Oh, can you pass me the failing test case?
Yeah, look at my screen. It's 1101, 1 operation.
1101, one operation should be 1.
Yeah.
1101.
Because that's if you flip the first bit. In my algorithm, I had the first
I got
bit
it.
set.
No, I got 2. Wait.
Yeah, you also
Why
got
did
2.
it say
Because,
the first bit?
yeah, if you flip the first bit, it would only take 1 operation, and the shortest length would be 1. You have 0, 1, 0, 1 in 1 operation.
I think we're cooked, bro.
I think we're cooked.
Woman and Jula.
Yes, we are very Jula. I'm writing the most spaghetti shit in the world. Oh man. Oh man, the guy got it in the chat.
Damn.
I think
That will be
he used our idea, but he's just better at implementing it. Or I don't know. I think he just already knew from the beginning. Okay, 1, 1, 1, 1, 2. Oh man, I just got wrong answer somewhere else instead. Fuck. Wait, why did I output 1? Oh fuck, because that would... Wait. Oh, but here would cost me 1 operation, so I should set this operation ops 2 cost 1 operations to do the initial one. Output 2. Fuck. Wait, what? Is this an edge case if ops equals 2? 8 and 0. Oh, I didn't take into the case of 0 operations. Oh, wait, no, if ops. Yeah, would take no operations to the length of 0. Why did it return 2? What the fuck? If I have 0, 0 in the previous one, what would happen? Yeah, still 2. Oh yeah, expected 2. But here, what is it? Output. Outputs 2. Wait. Outputs 1? Here outputs 2. Wait, am I good now? Did I fix anything? I think so. Man! 947 out of 949 hidden for this test case during contest.
Oh, what the hell?
Oh man.
We're cooked.
We're cooked. But the solution was so fucking close.
Why are you opening battle?
I clicked it by accident, man. Why are you looking at my screen? I was clicking Discord, but Valorant is right next.
Sure.
But bro, I'm not even
Jesus.
connected. I used to be addicted to WoW, but now you see I'm not even connected.
Very good. 非常好.
Oh man, the guy on YouTube said he got Q3, but Q4 is getting TLE'd. 945 out of 968.
But I'm so pissed. I don't know how to implement this, and I don't think our idea even works.
I think it works.
How do you
It's just missing
how do you
something.
fix the first bit?
Oh, the first bit. It's dumb. I just did the same thing, but I flipped the first one and I put number of operations equals 1.
Oh, what? Like our algorithm is pretty different, I think.
But like it's close. It's just missing something, because I feel like it's too cheese to just flip the first one and do the exact same thing. Ah, man.
Dude, I have to pack. I'm leaving tomorrow.
I don't know why it's failing. It's wrong answer. The idea was good though. It was a good idea. Just missing something. I think that's a 2.5 out of 4 in my books. Man, why doesn't it work? Makes sense that they hide the last test cases though, because you can just do if input is this, then output that.
Yeah.
La dépression. La dépression.
La dépression?
Oui, la dépression.
C'est correct.
This is the full solution. Can I zoom out?
C'est juste un jeu.
C'est juste un jeu. It's okay, we learn from it. I don't know. It's like this cancer binary search here. Oh, but it's missing something. Close enough though. I looked at the daily today. I have an n-squared solution.
I haven't looked at it yet.
The one yesterday, I was too tired and I didn't know how to do it. How do you bisect left in C++? I don't know. Ask ChatGPT.
There's bisect left in C++ as well. Oh, it's called something else.
I'm sure it has it. Because I think Python's bisect left is implemented in C++.
Yeah, it's called lower bound.
Lower bound.
But it's the same thing.
On Q3
Bro,
or Q2?
By the end of the year 2025, we gotta become Guardian.
Guardian. Wait, is it like based on your rating?
Rank. Yeah.
How much LC rating do you need?
To be knight, you have to be top 25% of Leetcode.
To be a knight? 25% of contest or 25% like...
No, actually, sorry. It's like top 20,000 people or something.
Because right now I'm like top 37,000 people, I think. Or more than that.
Yeah. No, you gotta be 25,000 people, I think.
We're pretty close already. Wait, 24,000? That's like a rating of like 1,700-ish?
Yeah. 1,700, something like that, yeah.
Are you using the space search array? Filling it up takes O of n. For which question are you talking about? Question 2 or 3? I think he's talking about question 2.
GG.
Yeah, GG. It's over. 2 out of 3 though. 2 out of 4. We're still on average.
Yeah.
Not
bad.
Wait, ask Chat to come. Contest over. Come complain with us. I wonder if Jeff had that binary search idea, but honestly, it was your idea. It wasn't mine. You came up with it. Rank on today's contest. Let me check. Man, I'm fucking shaking, man.
Why? Why are you so nervous?
I don't know. I just get so fucking nervous doing contests.
No shot that question isn't DP.
Yo,
No, it was binary search.
What?
Yeah. Do you want me to explain you the approach?
Did you solve it?
We were
No,
almost
we couldn't implement
two test case off. There's something like missing.
rip.
Yeah, but I'll explain it to you. Okay.
Okay.
Let's take this string here, right?
Yeah.
The biggest substring repeating is 4, right?
Yeah.
So you know the answer is somewhere between 1 and 4, right?
Mhm.
So let's pick 2, okay?
Oh, it's one of these fucking questions
Yeah.
where you just binary search the whole answer space. Oh my god.
Yeah. So
It's one of these fucking questions.
you see where it's going?
Yeah. Just try fitting it in as like at most.
Yeah, so
Try.
this, and then you're forced to flip this one, so that's one operation. Here it's another
And
operation.
then if it's not, then increase it. If it's less, if it's possible, then decrease it, and then just take the last answer that worked.
Yeah, but there's a little catch. There's a failing test case that I resolved, but it was very cheese. The test case would be like I think it's 1101, right?
Yep.
And I think the expected is 1, so you have at most the substring is at most 1, right? So if you did that with 1, then here you see there's a repeating, so you flip this one, right? And then you
No,
flip
you
this
do the
one,
first-
and then you flip this one. So that would take 3 operations, but it would actually cost you 1 operation if you only flip the first one from the start.
Mm,
Do you see what I mean?
it's interesting.
Yeah, so what I did is very cheese. Is I did the same loop, but I set the operation as 1, and I flipped the first character.
Okay, here's my DP idea. Basically, like at each you just step through the string, and at each step you can either flip the bit or don't.
So it's like you're doing every combination.
Yeah. So like if you how do I phrase this? So like you keep the certain number of operations left, right? In your like you do their DFS, and then first
Okay.
you check the next. So you're at index I. You check the next character. If it's different, then you just continue. And then you also keep track of like the current segment length. So let's say you're in that string of 1s. So like the segment length starts at 1,
Here.
and then the second character is the same. So you just the second character is the same. So you can either here's the choice. You either split it. So that means you flip the bit you're currently on to 0.
Either you
Right.
flip it.
No. So like let's start at I equals 0, right?
Can you hear?
Yeah, so I equals 0. There's three states to keep track of. So you have the index, the number of operations left, and the current segment length. So you check the next bit. It's the same, right? So you have 2 choices. You can either flip the current bit to reduce the segment size, or you can continue. So if you flip it, then on your recursive call, you skip to the bit after, so I plus 2. You reset the current segment the current segment length to 1, and
So
then
you start from here basically.
you set, and then you subtract 1 from the operations.
You
And-
have 1 less remaining operations to use because you flipped that one.
Yeah. and then if you continue, then you just increment the current segment length.
But that's like is that like trying all the cases?
Yeah, basically, and then
Yeah.
you slap a memo on it.
Yeah, you slap the memo on
I don't know if
it.
it worked. I don't know if it
But like,
works, but since
does the memo ever get used?
um, if
I
if
guess
you take
like
yeah,
if
because
you're
you
wondering,
can take the same path. You can take the same path to. You can take a lot of different paths to
yeah,
the same
let's like you have like
sequence.
this remaining, and you're wondering how many operations.
Yeah,
Yeah, something like that. Okay, I see like how it would work. But
yeah, and I don't know if this would scale to because the question 4 is literally the same question except n equals 100,000.
yeah, I was thinking about doing like some kind of like
Did it work for
DFS.
you?
I don't
Did you
think
code it up, Jeff?
I did code it up, but I didn't get the chance to submit it. Like I couldn't get it to actually work because there was some, like I couldn't implement it properly. But that was the idea, I guess.
Okay.
Okay. Yeah, the binary search idea we got 947 out of 949. Oh, it shows me the one that it shows me. Wait, does it show me now? The one that
Yeah, it did.
Okay, it's this one. Output 3 expected 2. What the fuck? Okay, let me try. Oh man, such a long fucking string. How is it 2?
Can I go find the
Your
problem?
cheesy solution for the first bit is I don't think it's gonna work.
Wait, I want to see what happens if I'm gonna manually do it.
There's some solutions where you.
So it's 2. Okay, so then you don't flip. 1, 2, and then you flip this one. So this one becomes 0. And then, oh wait, wait, here I would create, would I be creating another operation? I think so. I think in my current implementation, what I do is if it's not equal, oh no, if it's not equal, then I just continue. Yeah, I think that's fine. Let me check. Yeah, if they're equal, then I do some kind of logic, and if they're not equal, yeah, so I just append, and then the count bit resets so it doesn't flip. So then 1, 1, and then this is 0, so that's another flip. And then 1, 1, and then another flip. And 1, 0, 1, 1, 0, 0, 1, 0, 0, 1, 0. 1, 2, this would be a flip. Another flip. Another flip. Okay, another flip. So that would be 1, 2, 3, 4, 5, 6, 7. Okay, so that would be too many operations. Because we have 6 operations.
Yeah.
So then the other way.
I assume this scales to the question 4 too, because it's n log n, right?
Yeah.
So it will pass.
It should pass. I think this solution would pass the question 4. I think it's the optimal solution. But I'm not sure. So doing it like without flipping the first one takes 7 operations. Otherwise, it's 1 that we start with, which would cost 1 operation. And then 1, 2, and then we flip. And then this one we flip. No flip. Wait, but would the rest of the counts be the same? Because it wouldn't affect the rest, right? So are we like wasting operations for nothing somewhere? Oh man. So here,
I don't know. The idea makes sense. I think it should work. It's just like an edge case somewhere.
Yeah, there's an edge case somewhere, and it's bothering me. Man.
Well,
Wait,
I think
so
it has
what
to
is this
be
for
the
k equals
cheesy
2?
fix, flipping the first bit, because in that case, you set the number of operations to 1, right?
Yeah, if I flip
when you
the
flip in the
first
first
one.
bit.
Yeah.
Yeah, but you can do more than that.
What else could you do? Like flip the second one? Oh yeah, you could flip the second one.
No, but I'm saying like you can flip the first one, right?
Mm-hmm.
And then maybe the right solution is starting from the first bit, and then you just I don't know, you just flip some others throughout the string.
Because like
Right.
the initial solution is just like you read it until like the limit was 2, so once there's a third one, then you just flip it. And then there was an edge case where I noticed that like if I don't flip the first one, then I'm cooked. So then I just hard force the first one to be flipped. But I think that's cheese.
Can you try something? Like, can you just try to redo the entire thing, but like reversing the string?
Reversing the string.
Yeah.
Okay. So then it does the same thing. So operation is 0, and then this this array still as 0. Count bits is 1, but instead I reverse. Also instead
just
0 would
s
be
equal s minus.
so
Just
here it'd
put the entire thing.
Okay, yeah, I can just I could actually
just copy the entire thing, and just do s equal to reverse x. S. Yeah.
Yeah, and then is this
everything else the same?
Yeah, I think the rest is the same as this one, right? Oh, what?
Yeah.
Wait, oh no.
Yeah, I told you.
This test case didn't get added yet.
Oh.
Yeah, so how do I run it? Where's the run button?
Refresh the page.
Oh.
Because you're still in contest mode.
Okay. No, wrong answer.
Okay. Forget about everything I say is wrong.
Yeah, I don't know, man. But I have to go to the gym.
Dude, check my Strava tomorrow as soon as you wake up.
Your Strava, man. I'll put you on notification. How was that?
I'm gonna run a marathon.
What? Marathon? Are you like? Is it an official marathon or just solo marathon?
No, for fun.
Oh my god.
Because my flight is at 3 p.m, so I'm gonna wake up at 3 a.m. and like run a marathon.
Wait, okay. Or how do I set notifications again? I forgot.
No, you don't have to. Just like when you wake up, just check my profile.
Okay, I might forget, but I post it in your story. That way I'll see it for sure.
Okay, I will.
Alright, thanks for watching, everybody. Another 2 out of 4 contest. But our ranking's going up. This time I'm at 2.4k. Last time was like 3k something. I think you got better because I was inting my submits last week.
Did it not count the wrong submissions you had today?
What do you mean?
What do you mean?
Because you had some wrong submissions on the third question. Right?
Huh?
Did it count them as penalties or not?
For Q3?
It doesn't count. It only counts it as a tiebreaker.
Oh.
But for Q3, like the wrong solutions don't count because I didn't solve it.
Yeah.
It only applies the penalty if you solved it.
And what's the penalty like? It just like decreases your score?
No, it increases the time that it like the time that it took you to solve it by 5 minutes every.
Okay, and that basically influences your score.
Yeah,
your ranking.
Because your ranking is the time it took you to finish the questions that you did.
Oh, okay. Sure. Okay, cool.
Yeah, so it's all up to speed, like the speed of your solution getting accepted.
Yeah, that makes sense. All right.
Bye bye.